Hello everyone, welcome to my first video and Happy New Year! Today we are diving into one of the most important parts of a successful VEX season, setting up a solid professional code base. Whether you're a rookie team or looking to level up your workflow, having an organized foundation is what separates a good robot from a consistent one. In this video, I'll be showing you my setup for code that works every time and wins matches. Now, the first thing you'll need is obviously a code editor. VEX Code is great and all, but if you really want the best features, you're going to want a more advanced editor. What I will be using and what I seriously recommend is Cursor. Cursor is built on top of VS Code, so it is very similar to what you already know and love. It also happens to totally embrace AI, using Claude to help you accelerate your coding. More on that later, and don't worry, it is totally legal. Just download Cursor from the web, sign up for a free account, and you are ready to go. Now that you have your editor, you are going to need a place to store your code. Open up Finder or your file's alternative and create a new folder for your code. I'm going to name mine Robot Code. I know, very creative. Once you've done that, you can close this window and open up your editor. Once you are in, click Open Project and select the file that you just created. And now you are in. You have your agent on the right and your files and other tools on your left. We now need to add the VEX extension. Go to your Extensions tab and search up VEX Robotics. You're looking for this first one here. Now, make sure you have that installed and also pin it to your hotbar so that you can easily access it for later. Now close this. Now open up the new extension and create a new project. This step is crucial. Without creating a project like this, you will not be able to download code to your robot. Now for this tutorial, I am using V5, but you can also code with IQ using the same method. Now click on V5, and now we get into the coding. This tutorial will be in Python, but if you use C++, stick around to see what functions I create to make the rest of the season a breeze. You are now fully set up. We have a few extra options here at the bottom for downloading to the robot, and some actual code files. These ones in the VS Code, you don't want to touch this. These are just things for setting up a robot, and you don't want to change any of that. Inside the source, we have the main.py. Now, this is where you will be writing all of your code. You can see it's given you a little bit to start with. We have the functions for autonomous and user control. This is very important because in a match, when they flip it to autonomous and user control, you need to have your code in these exact functions. There is also some room right above these functions, right below the import. This is where you do all of the setup for your robot and create any other function that you will be using. This here is how I set up my drivetrain and controller. This adds 6 motors of my drivetrain along with putting them in 2 groups for less repetition in the code. I also add the controller here. For any other motors that I add, I do it in a very similar way, like this. Just defining another motor, like that. Pneumatics is also very easy. For pneumatics, you just define it in the same way, but also remember to initialize the piston by retracting it. I then assign each motor group a different sign, opposite values, so that they can spin in opposite directions and work together in a drivetrain. And the final part of the setup is setting all the motor velocities to 100% using a loop, like that. So now we have the drivetrain all set up through this, and a couple extra motors also added, along with initializing the controller, and 1 pneumatics piston. And we are also ready to start coding the drivetrain. Now, I know that was a lot, but if you ever need help understanding anything, or need to know the syntax of defining a new sensor, there is always help in the form of Cursor. Even if you know how to code, VEX brings in lots of new elements and it can be overwhelming. But Cursor's agent can help you as it has helped me. Of course, you can't vibe code your entire robot, but using Cursor to help speed up your coding by debugging and creating new functions is a game changer. And yes, it is allowed. Back to the drivetrain, I have added some more logic. We start off by initializing a couple variables here, speed left and speed right, and we create a few functions. We create reset all motors, which just initializes them, and set all motors velocity in case you ever need to change the speed of all your motors. Now for the drivetrain. We create a function move forward. This takes in the distance in inches you want to go and the percent of speed of your motors. Now, we start off by resetting all motors, which is always a good idea before any big operation. And we set a target. This takes in what we have given it, the distance in inches that we want it to travel, and that is times the 41.7. So, what this does is it tries to get the robot to move a certain amount of inches. That 41.7, that is the value that you are going to have to experiment with based on the friction, wheel size, and gear ratio of your robot. This is what has worked for mine and is equal to about 1 inch. So, we set all of the motor's velocity to the speed percent that we have decided, and then we move them all that same amount of distance and at that speed. After that, we have the turning. This is slightly more complex, but it takes in the degrees that we need to turn and speed. Now, this degrees times 2.1, that is again something you will need to experiment with on how much your motors need to turn 1 degrees. And very similar logic, setting the motors to a certain speed. And here, this is the logic that I figured out to get the robot to turn. And this actually is kind of complex, as you can see, but this was entirely created by Cursor. This is allowed because it is still your code and your ideas, but you can definitely use Cursor to help you with logic like this. So, now we have our drivetrain fully set up. And we have a couple functions like move forward and turn degrees. While in user control, this is not very useful. In autonomous, it very much is. It basically turns it into block coding. Remember I said at the beginning, for any auton code, you need to put it in this function, the autonomous function. So if I just paste in some example code, like this, you can see that these are all functions that we have created with move forward, turn degrees, and stop all motors. We already defined all those, like here. So now we can very easily edit and change the autonomous code whenever we need to, especially because it's a lot of trial and error. You can very easily change values and make sure it actually is doing what you want it to do without having to do a whole lot of code. Thanks to all the functions and setup we've done earlier, creating the user control is also very easy. All we do is bring in some global variables, and in this loop, this is the entirety of the code. All we do is check to see how much has the controller axis joystick been moved, and I used Cursor for some help with some of that logic. And then we just set some variables again, and you can see it's very simple. Just find the speed that we have to move the robot, and we use some more logic to determine turning, which I again used Cursor for help with. So remember, the key takeaways of all this are just define everything and make it as easy to use as possible. Make functions for everything. You do not want to be recoding all this stuff. And yeah, just use help when it's available. Thank you for watching till the end of the video, and I really hope this tutorial helped. See you in the next one. Bye.